All right, everybody, welcome. Week 4. This is lecture 7, so we're doing 214 twice. I always get distracted when I see myself on the camera. There I am. This is lecture. I think the wheels have come a little bit off the cart today, but it's all right. We'll find them eventually. Let's get into the shell. I had a couple questions. In fact, I'm just going to go out to my. Let me pause it for 1 second. Okay, so let's just start right off with a question. So Daniel said, he said he's getting the conversion factors wrong. Copied and pasted the economic functions, received different answers in the first set of values. So let's just go back and check on those. So really the next step here is to move from the ones we program by hand, and then get into the Excel programs. So let's
Functions?
the functions. There we go. So let's do that. I'll hop right on that. Okay. So this spreadsheet has pretty much everything written out. So let's just go through them one at a time. So remember, well, let's double check. Give me one more quick second. Okay, perfect. So the first thing to keep in mind here is what's the input and what's the output. So the easiest one to really identify is this A to P or the A to F, because they're sort of the big numbers, if you will. So the point is, let's just look at A to F first. So the idea is that I've got 10,000 I'm going to put in each year for 10 years. And if I did that at a 0% interest rate for 10 years, I would just come up with $100,000. But the fact is, I'm investing it at 7%, so it comes back as more in the future. Okay, so what I'm getting at is that the thing on the right goes in and the thing on the left comes out, just like you're writing a function in mathematics. Okay, so let's go back, and this is a nice little sheet because we can see that for doing, well, actually, let's start right here. The very simplest equation, is going from P to F. So if I take 10,000 bucks and invest it right now at a 7% interest for 10 years, my factor is simply that. It's 1 plus the interest rate, so plus 0.07 to the 10th power. And that's what's right here. So there's the factor, and then to get the value, we simply multiply P times the factor. Now, let's see what the function is for F, for the future value. So in this case, it takes 4 arguments. So the first thing it wants is the rate, which is an H5. There it is, 07. The next thing it wants is the number of periods. You can see it right there, N per, number of periods, 10. This is payments. Let's just take a look at payments. It'll give us a little Payments just means that you're not paying out, nothing's coming out, there are no payments. And then PV is whatever the present value is. The weird thing on this, and maybe you know, Sean, they put it in as negative. I don't know exactly why it's...
Because the present value is already spent, so it's a negative value. Compared to your future value is a positive number because you haven't gotten it yet. That's how I interpret it.
Okay, that's a good way to think of it, yeah. It's good, it's the best I can do. For me, it's just like, make it negative and it comes out positive. Make it positive, it comes out negative.
That's how I figured out a lot of my mistakes throughout this assignment is that simple little negative.
Yeah. So I guess the point to make here is that the function is just the FV function. And so we can see that in this case, the FV function, which is in row 9, comes out to be the same as our hard-coded function. There we go. All right, so let's just go to another one. So we did the simplest one. Let's go to the next simplest. Actually, I'll just keep it here. Okay, so this is, look, it's the inverse. So in this case, the factor comes straight out of the formula, right there. And this is the value we come up with when we multiply it by the future value. In Excel, we use the present value. So notice that instead of asking for the present value, it asks for the future value. There it is. And they come out to be exactly the same. So we did future value, which is FV. We did present value, which is PV. Two separate functions. All right, so let's look at the next one. And this assumes that we're going to have an annuity of $10,000. And what is that worth right now if we invest it for 10 years at an interest rate of 7%? So the point is here, if it was, you don't have to invest $100,000 right now. The fact is you'll actually have $10,000 10 times if you just invest $70,000 right now. That's the way to look at it. It's the present value of $10,000 a year for 10 years at 7% is only $70,000. That's the way to look at it. Okay, so let's see so there's the math. There's the factor with all the bells and whistles built in. Here's what Excel. So Excel is also asking for the present value, but in this case there is no. Well, in this case, there is an annuity, and the annuity is the $10,000. So that's where that comes from.
Okay.
So before it was zero, because we did not have an annuity. Now it's there. The future value is irrelevant. We don't want it. So we're looking at the present value, and there's the payment. So PMT is basically A in this case. Okay, so we got those first three nailed. Now let's look at the future to annuity. We've already done all of the math, the hard stuff. So there that is again. That's the value that comes up. We do the multiplication, and now in Excel, we're using the future value again. So we're trying to find F. So the rate goes in. Number of periods go in, the payment also goes in, there it is, in K4, and lo and behold, out pops the number. So the takeaway here is that if you had zero interest and invested $10,000 a year for 10 years, you'd have $100,000, but it's at 7%, so now you're at 138, more than you might have expected. All right, 4 down, 2 to go. So here's our factor, and now we're going from the present value to the annuity. Going from the present value to the annuity, there's the math we've already covered. The function in this case is payment. So just PMT again is A. So again, it asks for the rate, it asks for the number of periods, and it asks for the present value, because we know that. Those are the 3 things we know. Future value is not an option. To get the right number, it has to be negative, and there it is. So the take home is that if you have $10,000 now, it's the same as having, this actually sounds like a pretty good deal to me. $10,000 now sounds like a pretty good deal if you can get $14.24 a year for 10 years. That actually sounds like a pretty good deal. And so from the investor side, this is what the investors are looking at. I'm going to put in this much money now, I better get more back in the future. This is what drives the economy.
So this is the one I'm looking for. Well, not this specific one.
I mean, this is the one that the bankers are always fussing around with, right? Like, oh well, gosh, what if we got 11% instead? Whoo, almost 1,700. Oh, now we're talking. Well, shoot, maybe we need to do this. Oh, it's not even worth the trouble, right? So,
Almost a few years.
no. Okay, so those numbers match. Okay, one more to go here. Now this is the future values. This means we're going to have $10,000 in the future, and it means we only need $724 a year to get there at, again, that 7%. So again, since we're going to A, we're using the PMT function. There's the rate, there's the number of periods, and there's the present value of 0. So we don't care about it, and it's just the future value that comes in. So that's it. That is it. So I hope that answers the question from Daniel. I'm going to take a break, and I'm going to show you this kind of wild video. Give me a second.